Hello everyone, welcome to another lecture brought to you by 100% Dialog Group. So here we'll be looking at work time. So this is one of the most important topics which comes in any quantitative aptitude exam, and we'll be looking at 6 questions to basically understand the various concepts which are generally tested in this particular topic. Okay, so let's begin. Okay, so the first question is a person can complete a job in 120 days. So if the person does k units of work per day, then total work is 120k. Now he works alone on day 1, so he does k on day 1 plus on day 2 he's joined by another person who can also complete the job in exactly 120 days. So even the second person does k units per day. And on day 3 they are joined by another person of equal efficiency. Like this, every day a new person with the same efficiency joins the work. So basically in total n days, what will be the total work done? K plus 2k plus 3k n terms. Now how many days are required to complete the job? So this should be equal to 120. Okay, that is the total work. So we have to find n here. So applying the formula for 1 plus 2 plus till n, we know that it's equal to n into n plus 1 upon 2. This is equal to 120. Therefore n into n plus 1 is 240. So this is nothing but 15 into 16 is 240. Therefore n is equal to 15 is the required number of days here to complete the job. So we just use the simple unitary method to solve this problem, and as we will see further, all the work time questions I'll be solving using unitary method only. No short trick, this is the easiest one, and you should be able to solve each and every question using this particular method. Going to the second question, Amal can complete a job in 10 days. So Amal can complete it in 10 days. Bimal can complete it in 8 days. And Amal, Bimal and Kamal together can complete the job in 4 days. So if Amal does 1 upon 10 per day, so 0.1 units he does. Bimal does 1 upon 8, that is 0.125. And Amal plus Bimal plus Kamal, they complete in 4 days, so they do 1 upon 4, which is 0.25. So therefore Kamal per day does 0.25 minus the sum of this, which is 0.225, which is 0.025. Now they are paid a total amount of 1000 as remuneration. So they are to pay a total amount of 1000. If this amount is shared by them in proportion, then they have to find the Kamal's share. It is nothing but 0.025 of the total work done in a day equal to 1000. So 0.025 into 4 is 0.1 into 1000, which is 100. Therefore 100 is the share for Kamal. Okay, going to the next question, we are given works W1 and W2 are done by Priyanka and Sanjana. So Priyanka does W1, Sanjana does W2. Now Priyanka takes 80% more time to do the work W1 alone than she takes it to do together with Sanjana. So let's say Priyanka takes time T1. So W1 is completed in T1 times when Priyanka does it alone. So P is the work done by Priyanka per unit of time. Now she takes 80% more time to do the work alone. So let's make this 1.8 T1. Then the same work can be done in T1 time if P and S both work together. Again, S is nothing but work done by Sanjana per unit time. Therefore, this equation holds here. So what does this mean? Dividing the first equation from the second one, we get P plus S upon P is nothing but 1 upon, so P plus S upon P is, so let's put 1.8, this is 1. So P plus S equal to 1.8 P. 0.8 P is S. Therefore, P is 1 upon 0.8, which is 1.25. So P is 1.25 S. Now, how much percentage more time Sanjana will take to work W2 alone than she takes to do it together with Priyanka? So let's say Sanjana does a total work of K units per unit time. So Sanjana actually does S units per unit time and Priyanka does P. And P plus S is nothing but 2.25 S. So the total time taken would be 125% more if Sanjana does it alone as compared to when both of them do it together. Therefore, 125% is the correct answer. Okay, moving to the next question. We are given in 1/2 the time, Anil's father can do 3 times as much work as Anil. So let's take 0.5 hour Anil versus father. So in 0.5 hour, Anil's father can do 3 times as much work as Anil. So Anil does X. But it's not about 0.5 hour, it's half the time. So let's consider this. Anil's father is actually taking time t to do 3x and Anil is taking time, so t by 2 is taken by father and Anil is taking time t, because we are given in 1/2 the time Anil's father can do 3 times as much work as Anil. So if Anil's father is given full time as Anil, Anil's father will actually do 6 times work as much as Anil does. So therefore, if Anil does x work in that time, then Anil's father does 6x. Also, we are given Anil can do in twice the time 1/3 of the work as much as Anil's mother can do. So in one, he's doing twice that Anil is taking twice the time to do 1/3 of the work as Anil's mother is doing. So if Anil is given the same time as Anil's mother, he will actually just do 1 upon 6, because in time 2t he is doing 1/3 of the mother's work. Therefore, in time t he will do 1 upon 6 times the mother work. So again, for mother, the ratio is same as that for father. Now, if Anil's mother can do the job in 1 hour, how many hours will it take Anil's father to perform this job, which is 1 hour? Because we have the same ratio between Anil and Anil's father compared to Anil and Anil's mother. So 1 hour is the required answer. Now, moving on to question 5. Anil takes 9 days to complete a particular task while working alone, while Ajay takes n days to complete the same work working alone. Now, Anil and Ajay decide to work on alternative days. If they take exactly the same number of days, irrespective of whether Anil and Ajay start the work, find the number of positive integral values of n. Now, let's say we are given that irrespective whether Anil or Ajay start. So let's say Anil starts and Anil does 1 upon 9 work on first day, because Anil takes 9 days, and Ajay does 1 upon n work on the second day, because Ajay takes n days to complete the task. And similarly, third day again Anil comes, fourth day Ajay, and so on. Now it is understood, we are given that it should be equal to when Ajay start. So first day Ajay did, then Anil did, and so on. So one solution is very much clear from here, that for n equal to 9, the total days taken would be 9, because both of them are doing 1 by 9 work per day, and therefore irrespective of who starts, the total number of days taken would be 9 to complete the work. Okay, so n equal to 9 is one of the integral solution which we got directly from here. Now next point here is, we are given that irrespective of whether Anil and Ajay start, they are both finishing the job in same number of finishing the job in same number of days. So this is only possible if there are even number of total days. So let's say 2k is the total days in which the work is getting done here. So what is the total work done? K times 1 by 9 plus 1 by n. Because as there are 2k days, in k days Anil is working and in k days Ajay is working. And this is always equal to completed work. So this is equal to 1 because total work is 1. Okay, now total work is 1. So let's write n in terms of k here. We know k has to be an integer. So therefore 1 upon n is 1 upon k minus 1, 9, and n is 9k upon 9 minus k. Now we know that k cannot be greater than 9 because in 9 days alone Anil will anyways complete the task. So total days has to be less than 18. Okay, so now let's take different values of k and let's see for which value of k are we getting n as an integer, because we want positive integral values of n only. So k, it cannot be 1 because otherwise the whole work will be done in one day by Ajay only. So k, let's take it to be 2. 9 to 7, not an integer. K equal to 3. 27. 9 minus 3, again not an integer. So k equal to 4. That is again not an integer. So let's take k equal to 5. This is 40, again not an integer. K equal to 6. This is equal to 18. So n equal to 9 we got earlier, then n equal to 18 is also a possible value. Then we take k equal to 7. So this is again not an integer. And then finally we take k equal to 8. This is an integer which is 72. So there are 3 integral values of n possible here: 9, 18 and 72. Okay, so moving on to the last question now. We have 10 workers who are starting the job and they worked on it for 10 days. 11th day onwards, a new worker joined them every day till the job was finished. It took exactly 20 days to finish the entire job. So let's compute total work here. What is the total work in terms of man days? Okay, so for the first 10 days, 10 workers are working. So total man days is 10 into 10, 100. From 11th day, new worker joined in. So 11th day, total work done would be 11. 12th day, 12, and so on till 20. This is equal to total work. So here we can use the sum of an AP. So this is 2a plus n minus 1, which is 9 into 1. This is 255. So total work is 255. Now the same job has to be done starting with the minimum possible number of workers when it is known that a worker will quit the job every day after the first day. How many days will it take to finish the job in such a manner? So let the minimum number of workers be k. Then we know that total work done would be k plus k minus 1 plus k minus 2 and so on. This should be equal to 255. That is the total work. Why we are doing k minus 1? Because one worker is leaving each day. Now to minimize this value of k, we actually consider the sum till 1. So that we are taking the worst possible case when only one worker is left in the last day. Now sum of 1 plus 2 plus till k is nothing but k into k plus 1 upon 2 is equal to 255. Therefore, k into k plus 1 is 510. Now we try with different values of k here to get the value of k. So k 20, we have 20 into 21, which is 420. This is 510, lower than 510. So let's take k equal to 23. Now 23 into 24 is nothing but, so 230, 460 and 92. So 552. This is greater than 510. Therefore, we have to lower the k. K equal to 22. So 22 into 23. This is 460 plus 46, which is 506. But this is less than 510. Therefore, the minimum value of k here is 23. If we take 22, then the work will not be done, and therefore 23 is the minimum number of days that it will take to finish the job in such a manner. So this is it from this lecture. If you have any questions regarding this, feel free to post it in this particular FB group. Thank you.